Welcome to ICASSP 2020 Show and Tell demo. Is your hearing aid really working? In this video, we are going to show two different software tools, Tasker and openMHA. These tools should help you understand better how your hearing aid algorithm works in simulated and realistic scenarios. First, let's talk about the openMHA hearing aid.
openMHA is an open-source software tool that is tailored to the development and the evaluation of hearing aid algorithms. It has the capabilities that are required for real hearing aid processing, real-time low-latency multi-channel audio signal processing. It provides a complete hearing aid processing chain such that new methods can be evaluated in a realistic hearing aid setup. The software package comes with a set of reference implementations of processing methods from the literature that can be used in psychoacoustic studies, audiological research, or as baseline methods for own developments.
Well, so why would you use the openMHA? You might have your own tools for developing hearing aid algorithms.
So what you see here is our portable hearing lab. It features a box which contains the processing board and a self-made sound interface for multi-channel sound input and output. And connected to the device, we have this binaural behind-the-ear hearing aid headset, having two microphones in the shell on each side. And you will wear it like this, so you put it around your neck. It's lightweight, and then you can mount the hearing aids in your ears, and now you're wearing it like a real hearing aid and having hearing aid processing, but at the same time full control over all the stuff as a researcher. With this device, you can prototype the hearing aid algorithms of the future and test them in the wild.
Tasker is the second tool that we will explain in this video. Tasker is an audio engine for rendering virtual environments in real time. It can simulate from very simplistic scenarios to complex scenarios such as a cafeteria or a concert hall. It can simulate multiple sources, reflectors, and diffuse sources. And, at the same time, it can render to multiple outputs, such as multiple loudspeakers or headphones.
Now we have a virtual environment in Tasker, and this consists of an image source model, in which this image source model we have reflectors, sound sources, and receivers. And this image source model handles also room acoustic modeling, but in outdoor simulations like air absorption, for example, is also handled in the image source model. With this image source model, we can use Doppler. We can simulate Doppler shift and also the time variant comb filter effects. This is really important for outdoor simulations, but also for slow motion detection. If you have comb filtering, then self motion within rooms is detected based on comb filter effects. Okay, so now in this cafeteria we can switch off like the noise sources, like the direct noise sources, like the music and the other alternating speakers.
Ja, immer dann von 17 bis 1 Uhr. Das ist mir aber lieber als der Frühdienst. Mit dem ganz frühen Aufstehen kann ich gar nicht gut planen. Ja, doch schon tun, ne?
Mir bleibt ja nichts anderes übrig. Manchmal muss ich schon um 6 Uhr im Verteilzentrum.
And we can also switch off the diffuse reverb.
Eigentlich müsste ich dann mal früh ins Bett gehen, aber das klappt bei mir ja nie. Deswegen trinke ich morgens dann einfach ein paar Kaffee.
And we can switch off the early reflections as well. So we have full control of the environment because we can switch off all separate sources individually and control the complexity this way. So in Tasker we can also render all the target signals in one layer and all the noise signals in a different layer. And this way we can really measure in real time the signal to noise ratio. For example, we could interactively explore the environment, move around, turn our heads, and in real time measure the benefit of the device.
We made a great deal of way during the night, and we're now lying becalmed about half a mile to the southeast of the low eastern coast.
Gray-colored woods
Gray-colored woods covered a large part of the
even
surface.
tent was indeed
Tasker is very tailored to reproducible signs, and you can also integrate the openMHA, for example, and we can integrate other external tools. And with the feature of interactivity, we can render the movement behavior in real time together with the hearing aid processing in the lab.
Now let's take a look at the possible use case of developing a hearing aid algorithm. After writing the code and offline testing your algorithm, one would move to prototyping and testing your algorithm with listeners. Here comes Tasker and openMHA. With Tasker, one could generate simplistic and complex scenarios where you can test systematically your algorithm with listeners. This would be done in the laboratory. From these laboratory experiments, one could obtain both objective and subjective measures. Once the algorithm is working in the Tasker simulations, it could be implemented with openMHA and tested in the wild. In this case, qualitative data could be collected, and if some situations were found to be challenging, they could be recreated and implemented in the laboratory with Tasker. If you already have your implementation working with openMHA, you can use it in Tasker to process and simulate the hearing aid algorithm. Let's put an example. You write your code, let's say in openMHA, and you test it in Tasker in a couple of scenarios, like a cafeteria and a concert hall. You iterate your algorithm until it works very well in these scenarios. After, you let a participant test this algorithm on the wild for a week, and maybe this person will come back and will tell you that it worked very well in the cafeteria and in the concert hall, but he had problems when he was driving a car. Then you could implement a car simulation inside Tasker and improve your algorithm until it's also working in this situation. This way, you can be sure that your algorithm has the best performance before releasing it to the market. In our laboratory in Oldenburg, we are adding extra layers of realism such as visual cues.
Ja, genau. Es passiert nicht oft, dass alle so spontan vorbeikommen.
With these tools, we are developing future hearing aid algorithms that include gaze, brain signals, and acoustic scene analysis. For more information, please contact Herzke or any of the authors. Thank you for watching this.